Mr. Right here. We're going to find out how to find the nth term formula for an arithmetic sequence. Now, first of all, let's just be clear. An arithmetic sequence is a sequence like this one, 5, 8, 11, 14, where the difference between the terms is always the same. In this case, we've got a constant difference of plus 3. Now, how are we going to find the nth term for that? Well, the first thing to do is to ascertain what that common difference is. In this case, the common difference is 3. That means that my nth term formula is going to start 3n, because my formula is a bit like the 3 times table, and that has differences of 3. So if my formula has differences of 3, it's going to start with an nth term formula that begins with 3n. Now, if my formula was just 3n, then the first term of my sequence would be 3 times 1, 3. And the first term of my sequence is 5. So I'm going to need to have a correction factor of plus 2. Let's just check that works for the other terms we know. Let's choose this term. That's the fourth term of our sequence. And according to my formula, the fourth term is 3 times 4 plus 2. And according to the question, that should give me an answer of 14, which indeed it does. Let's look at another example of finding the nth term formula for an arithmetic sequence. Here's the sequence. You could pause the film, see if you can do this one, and then watch how I do it, see if we agree. So the sequence is 7, 11, 15, 19, 23. Okay, pause the film if you want to. Right, that's an arithmetic sequence, and the difference between the terms is always the same. In fact, the constant difference is 4. So my nth term is going to start 4n. Now, what's my correction factor going to have to be? Well, the first term of a sequence which starts 4n would be 4 times 1 is 4, and my first term is 7. So it's going to need to be 4n plus 3. And I could check that by looking at the fifth term. The fifth term I know is 23, look. And let's just check, because according to my formula, the fifth term should be 4 times 5 plus 3, and that is 23. Good. Okay, let's have a look at a couple more examples. Let's look at this one. 5, 13, 21, 29. Pause the film if you want to have a go yourself. This time, the constant difference is 8. So my formula is going to start Tn equals 8n. It's like the 8 times table. But 8 times 1 is 8, and my first term is 5. So my correction factor will have to be minus 3. And we could check that by looking at the third term, for example. According to my formula, the third term should be 8 times 3. Take away 3, which is 21. And if I look at the question up here, I see the third term is indeed 21. Right, last one. Let's have a look at this one. 21, 19, 17, 15, 13. Pause the film if you want to. In this case, the constant difference is minus 2. So my formula for the nth term is going to start minus 2n. Now, if that was my formula, then the first term, t1, would be minus 2 times 1. It would be minus 2. And my first term is 21. So I'm going to need to have a correction factor of plus 23 to lift that minus 2 up to 21. And again, we could check that. Let's check it with the fourth term. According to my formula, the fourth term is minus 2 times 4 plus 23. Well, that is minus 8 plus 23, which is 15. And looking at the question here, my fourth term is indeed 15. So that is how to find the formula for the nth term for an arithmetic sequence. If you found this film useful, please hit like.